For decades, Windows updates have been marketed as a necessary evil. Something users are told to accept because security matters and stability improvements are important, and yet, year after year, the same story repeats itself. A new Windows update rolls out, and suddenly millions of PCs around the world start behaving strangely. Computers that worked perfectly the night before refuse to boot in the morning. Printers disappear. Wi-Fi breaks. Performance tanks. Blue screens return like an unwanted ghost from the past. Forums explode with complaints. IT departments scramble to roll back patches, and everyday users are left staring at error messages they don't understand, wondering what they did wrong when the truth is simple. They trusted Windows Update. This isn't a rare event or an isolated incident. It has become a pattern so predictable that many Windows users now delay updates out of fear rather than excitement. Instead of being something that improves the system, updates are treated like a risky gamble. Will this one fix bugs, or will it introduce new ones? Will it improve performance, or will it quietly slow the system down? Will it work fine on most machines, but completely destroy yours? No one knows, and that uncertainty is the real problem. What makes this even more frustrating is that Windows updates are not optional in the way they used to be. Microsoft has steadily removed user control over the update process, especially in Windows 10 and Windows 11. Updates download automatically, install automatically, and reboot your PC automatically, often at the worst possible time. You can be in the middle of work, gaming, or a presentation, and suddenly your system decides that now is the perfect moment to restart, because an update says so. And once that update is installed, rolling it back can be difficult, confusing, or in some cases, impossible. Now let's talk about what breaking PCs actually means in real life. Sometimes it's dramatic, like a system that won't boot at all. You press the power button, see the Windows logo, and then nothing. Endless reboot loops, recovery screens, cryptic error codes. Other times, it's more subtle, but just as damaging. A driver update included in a Windows patch might conflict with your graphics card, causing crashes in games or creative software. A security update might break compatibility with older, but still essential applications. A cumulative update might introduce a bug that causes massive CPU usage, draining laptop batteries, and making fans scream for no apparent reason. And this isn't just happening to obscure hardware setups or ancient computers. Brand new laptops, business machines, and even Microsoft's own Surface devices have been affected by bad updates. There have been updates that deleted user files, updates that broke VPN connections for businesses, updates that disabled audio across entire systems, and updates that caused blue screens on startup for thousands of users at once. These aren't theoretical risks. They are documented events that happen again and again. The reason this keeps happening comes down to how Windows is built and how updates are tested. Windows is a single operating system expected to run on an almost infinite combination of hardware. Different CPUs, different motherboards, different storage controllers, different GPUs, different drivers from different manufacturers, all interacting in complex ways. When Microsoft pushes a large update, it's impossible to test every possible combination thoroughly. Instead, users effectively become the final testing stage. Problems are discovered after release, not before, and by then the damage is already done. Microsoft often responds quickly with hotfixes, but that doesn't help users whose systems are already broken. If your PC won't boot, a hotfix that requires Windows to run is useless. If your data is corrupted or inaccessible, an apology doesn't restore it. And for businesses, downtime caused by a bad update can cost real money, damage reputations, and disrupt operations. Now contrast this experience with Linux, and the difference is night and day. Linux users simply do not live in constant fear of system updates. That doesn't mean Linux is magically immune to bugs, or that updates never cause issues. It means the entire philosophy around updates is fundamentally different, and that difference changes everything. On most Linux distributions, updates are transparent. You know exactly what is being updated and why. Package managers show you a clear list of changes before anything is installed. You can see which packages will be upgraded, which ones will be removed, and which new dependencies will be added. Nothing happens behind your back. Nothing installs itself at 3 a.m. without your knowledge. You are in control. More importantly, Linux updates are modular. Instead of massive, monolithic updates that change half the operating system at once. Linux systems update individual components. The kernel can be updated separately from the desktop environment. Drivers can be updated independently of core libraries. Applications are often sandboxed or isolated, reducing the chance that an update to one part of the system will break everything else. And when it comes to reboots, Linux respects the user. Most updates do not require a restart at all. Even kernel updates, which traditionally require a reboot, can often be deferred until you choose to restart. Some systems even support live kernel patching, allowing critical security fixes to be applied without rebooting. The idea that your computer would force a restart in the middle of your work is almost unthinkable in the Linux world. Another key difference is how drivers are handled. On Windows, drivers are often provided by hardware manufacturers and distributed through Windows Update. This sounds convenient, but it also means Microsoft is pushing third-party code into your system, sometimes without the latest testing or customization for your exact hardware. A bad driver update can instantly destabilize an otherwise healthy system. Linux, on the other hand, includes most drivers directly in the kernel. These drivers are open source, reviewed by the community, and tested across a wide range of systems before being merged. When you update the kernel, you're getting a carefully curated set of drivers that are known to work well together. This doesn't eliminate bugs entirely, but it significantly reduces the risk of catastrophic failures caused by mismatched or poorly tested drivers. Then there's the issue of user choice. If a Linux update does cause a problem, rolling back is usually straightforward. Many Linux distributions keep older kernels installed by default, allowing you to boot into a previous version with a single menu selection. If a new kernel doesn't work well on your hardware, you can simply keep using the older one until the issue is resolved. On Windows, rolling back a problematic update can be a confusing process involving system restore points, recovery menus, or registry changes, and even then it doesn't always work. Linux users also benefit from something Windows users rarely experience: community transparency. When an update causes an issue, it's discussed openly in forums, mailing lists, and bug trackers. You can see exactly what went wrong, who is working on fixing it, and when a solution is expected. You're not left guessing or waiting for an official statement that may never come. This openness builds trust, and trust is something Windows updates have steadily eroded over the years. It's also important to talk about the pace of updates. Windows updates often try to do too much at once. Feature updates introduce new interfaces, new behaviors, and new background processes alongside security patches. This increases the chance of something going wrong. Linux distributions typically separate these concerns. Security updates are prioritized and kept small. Feature upgrades are optional and often tied to major version releases that users can choose when to install. For example, a Linux user running a stable distribution can stay on the same version for years, receiving security updates without major changes to the user experience. This is especially important for professionals who rely on their systems for work. They don't want surprises. They want consistency, reliability, and predictability. Linux offers that, in a way Windows increasingly does not. Another factor is hardware lifespan. Windows updates have a history of degrading performance on older machines. New background services, increased telemetry, and heavier system requirements slowly turn perfectly usable PCs into sluggish frustration machines. Linux updates, by contrast, often improve performance, or at least maintain it. Many Linux distributions are famous for breathing new life into older hardware, not slowly killing it. This is why you'll often hear stories of Windows users updating their system, only to find that it now runs hotter, slower, and louder than before. Fans spin constantly, battery life drops. Simple tasks feel laggy. On Linux, updates rarely have that effect because the system isn't constantly expanding with new background features designed for data collection or ecosystem integration. Security is another area where Linux updates shine. Windows updates often bundle security fixes with everything else, making it hard to know what's critical and what's cosmetic. Linux distributions clearly label security updates, and because the update process is fast and unobtrusive, users are more likely to install them promptly. When updates don't feel dangerous, people don't avoid them. This leads to a healthier ecosystem overall. Linux users tend to keep their systems up to date because updates are seen as helpful rather than risky. Windows users, on the other hand, often delay updates for weeks or months out of fear that something will break. Ironically, this means Windows systems can remain vulnerable longer, even though updates are forced. The difference in mindset is striking. Windows updates feel like something done to the user. Linux updates feel like something done for the user. That single distinction explains why one platform is associated with constant update horror stories, while the other is not. Of course, Linux isn't perfect. There are edge cases, especially with very new or very niche hardware, where updates can cause issues. But the scale and severity of those issues are usually far smaller, and the recovery options are far better. A Linux update might break a specific application or driver, but it's extremely rare for an update to render an entire system unbootable without a clear path to recovery. And perhaps most importantly, Linux users have a choice. If you don't like how one distribution handles updates, you can switch to another. Some distros focus on cutting-edge updates, others prioritize long-term stability. You can choose rolling releases, fixed releases, or long-term support versions. Windows users don't have that luxury. There is one update system, one schedule, and one set of rules, whether you like them or not. As more people experience repeated update failures on Windows, it's no surprise that Linux adoption continues to grow. Developers, creators, and even everyday users are realizing that a computer should be a tool, not a liability. It should work for you, not constantly demand your attention with forced restarts and broken patches. When you hear someone say, "My Windows update broke my PC," it no longer raises eyebrows. It's expected. When a Linux user says an update broke their system, it's newsworthy precisely because it's so uncommon. That contrast tells you everything you need to know. In the end, this isn't about hating Windows or pretending Linux is flawless. It's about acknowledging a real, persistent problem and recognizing that a better model already exists. Windows updates are breaking PCs because they are centralized, forced, opaque, and overly ambitious. Linux avoids this problem because its update system is decentralized, optional, transparent, and respectful of the user. As long as Microsoft continues down its current path, Windows users will keep bracing themselves every time an update notification appears. Linux users, meanwhile, will keep clicking update, confident that their system will still work exactly as expected when it's done. And that peace of mind might be the most underrated feature of all.